So let us start one most important part of algebra, that is complex numbers. Now before going for the basic concepts of complex number, we should know what are they. Because till now we have studied about the number system, we have studied about the real numbers, especially in which contains the natural numbers, whole numbers, real numbers, rational, irrational, all these comes into the category of real. And there is another part which is known as the complex numbers. So before going for that complex number, we should know one important part here, which is the symbol I, italic style I. That is, it can be written like this, it is also written like this. So this is spelled as iota, where iota is nothing but square root of -1. That means whenever we are having -1 inside the square root, we say that this one is a number which is not real. This is making any number an imaginary number. So first we should know what are the basic concepts, because here we know how to get rid of that square root. We are going to do squaring. Now when we go for squaring, this is iota square is equal to -1. So there are important properties of this iota. Let's go for those properties. The different powers of iota that we have already studied in the previous class, where you can see that iota which we have written as square root of -1, and when we have squared that one, that is iota square which is equal to -1, we can predict few values. That means few properties can be derived from this. That means again if I go for multiplying this one, that means I am finding iota cube. When I find iota cube, this will be iota square into iota. And iota square, we have already taken this one as -1 and this is iota. So as a result, we are getting the term iota. Now, if I go more further to this one, if I want to find for iota to the power 4, that means I am going to find iota square into iota square, which is equal to -1 into -1. So as a result, we are getting 1. Now, to understand the pattern, let us go for the next part over there, where I am going for iota to the power 5. Now, this iota to the power 5 will be iota to the power 4 into iota, which is 1 and this is iota. So, as a result, we are getting the term iota. Now, just see the pattern. Here we are having iota. Now, when I go for iota to the power 6, this is iota to the power 4 into iota square. This is nothing but 1 into -1. As a result, we are getting -1. See the next pattern, we are having -1. And again, if I go for iota to the power 7, which is iota to the power 6 and iota. Iota to the power 6 is -1 and iota, when they multiply, we are getting minus iota. So the terms are repeating, and at last when we go for iota to the power 8, it is iota to the power 4 whole square, which as a result is 1. So what we can see, the values that we are getting is we are getting first number as iota, then we got -1, then we got minus iota, and then we got 1. So that means there is a cyclic pattern over there. You can see this cyclic pattern. It is somewhat like this and it is going to repeat. Now these values are going to repeat. So one thing we can say that we are getting 1. When we are getting 1, we are getting 1 whenever iota is having power 4, power 8 means power 12, power 16, power 20. So it will be a multiple of 4. So that means this term will always be obtained whenever it is iota to the power 4n. So that is what it is written, that iota to the power 4n will always be 1. And when we go with the power which is more than this, so more than this means this will be iota to the power 4n plus 1. So the result is iota. So that is what it is written here. Iota to the power 4n plus 1 is equal to iota. And when I increase one more power to this one, means iota to the power 4n plus 2. So we can remember this one as an even number but not a multiple of 4. The result we are going to get is -1. So it is written over there. And again increasing one more power, that is iota to the power 4n plus 3. The result is -1. So minus iota, sorry. So this we are having a concept. So we can also remember this one. That means whenever the number is more than a multiple of 4, the result is iota. Whenever it is less than, So iota to the power 4 and minus 1 can also be remembered. So this value will be minus iota. So these are few important properties. That means if we are having different powers of iota, we can remember these different properties and we can solve the questions. So let us take a question which is basically dealing with different powers of iota. Now this question is, when iota, this I is nothing but square root of minus 1, then we have to check that 1, I am writing it here. So they are asking us to find 1 plus iota square plus iota cube. Then they are saying iota cube minus iota to the power 6, and this is iota to the power 8. Now here, first of all, we should remember one thing. That means whenever we are having even powers, that means 2, 4, 6, 8, they will not be going to get iota. Iota will only be obtained whenever we are having iota cube, iota 5, iota 7 and so on. That is odd numbers. So here we are already having 1. This is iota to the power 2, but it is not a multiple of 4. So result will be minus 1. Iota cube, as we have studied, it is 1 less than power 4. So we are getting minus iota. And here this is even again. So I am getting minus of 1. And this is a multiple of 4. 8 is a multiple of 4. So this result will be 1. So we are getting 1 minus iota plus 1 plus 1. So we are having this 1 and 1 getting cancelled. The result is 2 minus iota. So please don't do the mistakes over here. Generally the students used to predict this one as that the result will always be when we add them, and just what you have to do is you have to apply the basic concepts very properly. That means you have to remember only one thing: whenever it's a multiple of 4, the result is 1. Otherwise, if it is an even number, that means if you are having 2, 6 and say for example 10, so these numbers will be minus 1, and by putting those concepts we got the result which is 2 minus iota. Let us take one question which is having all the even powers. That means iota to the power 2, iota to the power 4, iota to the power 6 and so on. And we are having terms up to 2n plus 1. Means we are having even number of terms, that is plus 1, means 1 more than an even number. So if I just expand this one, you can see that this is iota square plus iota to the power 4. These are two terms. Again iota to the power 6 and iota to the power 8. Again even number of terms. And again if I go with iota to the power 10 and this is iota to the power 12. So this is an even number. Suppose that we are having odd number of terms, that means 2n plus 1. So for even numbers, the pair is giving you the answer. You can see that this answer that we are getting is minus 1, and for this it is plus 1. So the result is 0. For this one also minus 1 and plus 1. The result is 0. That means for even number of terms we are getting the result 0. And when we say that odd number of terms, means this term will come into existence. So iota to the power 10 will give you minus 1. That means whenever we are going to take even number of terms, result is 0. Whenever we are taking one more than that, this a multiple of 2 will come, which is not a multiple of 4. So this will always give you minus 1. So the result here is D. So for this particular question, the result is minus 1. Let us take one more question. Now this is having big powers, that is iota to the power 592, 590, 588, 586, 584. So what we can see, again we are getting even powers. So what you can do, let me write this one as iota to the power 592, iota to the power 590, this is iota to the power 588, this is iota to the power 586 and iota to the power 586, and at last we are having iota to the power 584. Clear? Now after 584 we are having the terms in the denominator, but before if I go for the next part, let me simplify this one. So we can see that iota to the power 584 can be taken common. So out of 584, this term will become 1. This will become iota square, and here this will become iota to the power 4. This becomes iota to the power 6, and this becomes iota to the power 8. Now this you have to simplify this one, because this result we are getting 1. This is minus 1, this is plus 1, this is minus 1, this is plus 1. So we are having 0, we are having 0, we are left with 1. So that means if I take the numerator part, we are having iota to the power 584. Now this 584 is a multiple of 4. Clear? If this one is a multiple of 4, the result will be 1. That means for this numerator part, it is getting 1 as the result. If I go with the denominator, again the same concept, I can go with the lowest power. We can take that iota to the power 574 common. Again we are left with 1 at the last. Then here we are going to have iota square. Then we are having iota to the power 4. And then again if I go with this iota to the power 6. And this is iota to the power 8. Now dear students, if you don't go for this simplification part also, you can see that the numerator is like this and denominator is like this, where this term again can be cancelled. So you can also do it in the same format. Now this is a multiple of 4 and in the denominator we are getting iota to the power 574. Now this 574, if you go for this 574 is not a multiple of, it's an even number. Clear? If it is an even number and again it's a multiple of 4, because for multiple of 4 we remember the last 2 digits. If I go with the last 2 digits, they should be a multiple of 4. So what we can see that here this is 84. So when we divide by 4 we are getting 21, and if I go with this one, so we are giving 34. So this is not a multiple of 4. This one is a multiple of 4. So this will give you number 1. This will give you minus 1. So overall result we are getting minus 1, and this is minus 1 and minus 1. So result will be minus 2. So I have told you, I have given you 2 different methods. One is we can go with the simplest form. We are getting the term, or we can also do simplify the numerator part, which is like this. You can take that iota to the power 584 is taken common, then it is iota to the power 574 is taken common, and at last we can simplify this one to get the result as minus 2. Let us take one more important question where we are having this summation sign. Summation sign means we are going to add by putting n is equal to 1 to this one, and n is equal to 2, n is equal to 3 till we are getting 200. Now if I just simplify this thing, so we are having iota n, which is being summation has to be taken for n is equal to 1 to 200. That means what we are going to put, we'll be going to put this n is equal to 1, then n is equal to 2 and so on. How we can write this one? This becomes iota to the power 1, iota to the power 2, iota to the power 3, iota to the power 4 and so on till we are getting iota to the power 200. Now if I just take a pair of 4, you can see that here we are getting iota. This one is minus 1, this is minus iota, and this term is plus 1. So plus 1 minus 1 getting cancelled, iota minus iota getting cancelled. So when we take a group of, that is if you take the natural numbers 1, 2, 3, 4, that is taking you can say a group of 4, 4, 4, 4. So the result we are getting as 0. That means for the next again 4. So since this one is a multiple of 4, 200 is a multiple of 4, that means this will also come into the last member of that last group we have taken, group of 4. So the result is definitely coming 0. So we can say that for these type of questions we can directly go for the answer 0. Now we have studied about iota completely, different powers of iota is there. Now we can give a proper definition to the chapter which is actually complex number. What is a complex number? So the first thing that will come into the mind, that how to define a complex number. So dear students, if I take any two real numbers, if I say x and y are any two real numbers, then the form in which a number will be added to another real number which is containing iota, then this is the Cartesian form of a complex number, where the complex numbers are generally denoted by small letter z, and the number which is in the form of x plus iota y, where x and y are real numbers, where I we already know it is the iota, this is known as a complex number, and I is iota as we have already studied. Now when we collect all the complex numbers, that means as I already told you it is denoted by z, means for example if I take any two real numbers, say 3 and 4, 3 and 4 are two real numbers, so writing 3 plus 4 iota or writing 3 plus iota 4, this will give you a simple Cartesian form of a complex number. This will be denoted by z. If I take one more, say for example, I am having root 2 and I am having minus 1 upon 5 like this. These two are also real numbers. So root 2 minus iota upon 5. This is again a complex number. Let us say this is z1 and this is z2. When I collect all these type of complex number and make a set, and that set is denoted by C. That means set of all the complex numbers where they all are having the form x plus iota y, where x, y both are real numbers and I stands for iota. So this is how we can write a complex number which is having a form here x plus iota y, which is known as the Cartesian form of a complex number. So there are three different types. Three different forms are there in complex number. So this is the first form, Cartesian form of a complex number. Now let us conclude what we have studied till now. So if we say that a complex number z, which is written as x plus iota y, where x and y both were real numbers, that is x and y both belongs to the real numbers, then specifically this x will be, as it is not having that iota, x will be known as real part of z. In short, we write this one as REZ. In the same way, when we see that in this complex number, this iota is there with y. That means the y will be, this real number y will be given another name that is known as imaginary part. So it is imaginary part of z. In short, we write this one as IMZ. Let me take one example. If I take, say z is equal to 5 plus 3 iota, then as we can see, iota is there with 3 and 5 and 3 both are real numbers. Still we can write this 5 is the real part of z and 3 which is containing iota, then 3 is known as imaginary part of z. So this is how we write a complex number as x plus iota y, where this is known as Cartesian form of complex number. Now, if we take a complex number, and there will be two terms that you will come across with the questions, that is purely real and purely imaginary. So when we say about a complex number z which is purely real, it means that imaginary part is not there. So it is having only the real part. Say for example, z is equal to 5, only 5. So this is also giving you an hint that every real number can be expressed as a complex number because the imaginary part is 0. So we can write this one as 0 iota. Whenever such is the case, we say that this z, let me take z1, this z1 is purely real. Now in the other way, if I say that there is a complex number which is containing only iota term, that means it is known as purely imaginary if the real part of the complex number is 0. That means if I am saying that 3 iota, there is nothing written with that. So this term, this complex number will be called as purely imaginary because there is nothing. If there is nothing, we can write this one as 0. So just you have to keep this thing in mind. Whenever a complex number is purely imaginary, so what we are going to put? Real part will be 0. Whenever we say that a complex number is purely real, we are going to put the imaginary part equal to 0. Now, after understanding the basics of complex number, basics means how a complex number is written, which is nothing but the Cartesian form. Now let us go for the algebra, that is the operations which are there in a complex number. So when we go with the operations, so let us take the first operation that we are having is addition. The other one I am taking as subtraction. Rather, subtraction we are not considering into the binary operations. So we know it is nothing but the additive inverse of any number. So first we should go with this complex number. That means if there are two complex numbers given to you, a plus iota b and c plus iota d, if there are two complex numbers given to you, addition, that means when we add two complex number, this will also belong in the same set. The property is if z1 and z2 are two complex number taken from the set of complex number, then their addition z1 plus z2 is also a complex number. Why? Because when we add them, the real part gets added and iota can be taken common from this one. You can see that if I take this iota term, this iota will be taken common and we are going to have c plus iota d. These two were real numbers. So this is again will give you a real number. This is again two real numbers b and d. They were real numbers. So they will also give you a new real number b. So what you can see that as a result also we are going to get a complex number. Say for example, if there is a complex number z1, say 2 plus 3 iota, and another complex number I am taking 4 minus 5 iota, like this. Clear? So when we add them, z1 plus z2, it is very simple addition plus 4 minus 5 iota. So what we are going to do, this is 2 plus 4 and this is iota common 3 plus of minus of 5. So the result that we are getting is 6 and this is minus 2. So that means the result is 6 minus 2 iota. So this is about the addition. When we say about subtraction, again subtraction will be going to give you a complex number in which, suppose if I want to subtract, now I want to find z1 minus z2, means if I put 2 plus iota 3 or 3 iota minus, it is 4 minus of 5 iota, we'll be going to apply simple concepts of algebra. That means whenever you're having a minus sign outside, just split them, that is minus will get inside, we will be going to get the result as minus of 4 plus of 5 iota. So the result you can see this is minus of 2 and this will give you plus of 8 iota. So the result also is a complex number. So these are two important operations in complex numbers. Now, the next operation that we are having is multiplication. That means whenever two complex numbers are given to you, z1 and z2, when we multiply, this is z1 into z2, that will also give you a complex number because it is a simple multiplication where a will multiply by c plus iota d and iota b will multiply by c plus iota d. So what you can see, the result is ac plus iota, this a will multiply by this a will multiply by d, na? So this is AD and here what will be going to get iota, this is BC, and dear student, this iota and iota is nothing but iota square into BD. So as a result we are getting AC, iota AD, and this is iota BC, this is minus BD because iota square is minus of 1. So when you put this one, we are getting AC minus BD. And iota is common, it is AD plus BC. So this is a real number, this one is a real number, this is written in the form of a plus iota b, that is the Cartesian form of complex number. So multiplication will also give you a complex number. Same is the case with the division. Whenever we are having division of two complex numbers, so what we are going to use, we'll be going to use a concept where rationalization is done. We know that this iota is nothing but square root of minus 1. So whenever we are having square root of minus 1 in our junior classes, we have studied about surds, where rationalizing the denominator concepts will be taken place. So if we are having a plus iota b and c plus iota d, then we are going to take c minus iota d with this. And as a result in the numerator they will get multiply. When they multiply, this is AC, then this is minus of iota BD. Rather first I will take AC and then this A will multiply. So we will write this one as AC minus iota AD plus of iota BC. Then this is minus minus plus I am writing here because iota square will give you a minus 1. So that minus will cancel. So this is only BD. Whole denominator we are having a plus b and a minus b, we can write this one as c square and minus of iota d whole square. So as a result we are getting AC plus BD and plus, then we can take out this iota common. Now from these two terms, you can see that in these two terms we are having that iota common. So what will be going to get? We are going to get AD plus BC, but this was having a minus sign. So I am going to put this minus sign here. Whole denominator, we are having in the denominator as c square, this is iota square again it is minus 1, so this minus minus getting plus 1, so this is only d square. So what you can see, the result that we are getting is AC plus BD whole divided by c square plus d square. So this is also giving you a technique how to divide two complex numbers, clear? And the other one is plus, you can see that iota is common. First I will take the positive term, AC minus, this is BC minus AD whole divided by c square plus d square. So this is again giving you another complex number which is having the form a plus iota b. So that means division also will give you a complex number which is having the form a plus iota b and a plus iota b, and same was the case here also. This is of the form a plus iota b. So whenever any operation is giving you a result which is in the form of a plus iota b, that will be considered as an operation, and whatever result we are getting is again a complex number. So this is how we multiply and divide two complex numbers. Now let us take the next part of complex numbers, which is nothing but the conjugate of a complex number. If we take a complex number, say for example 3 plus iota 4. So let me tell you that when we take the graphical representation, this particular diagram is known as Argand plane. That means if I spot this point 1, 2, 3 and this is 1, 2, 3, 4. So you can see that there is a point over here. This point is nothing but 3, 4. So when we join this one, so from the origin to this particular point, this is a presentation, that is the Argand plane, that is the graphical presentation of a complex number. So conjugate means just we have to change the sign of imaginary part, that is minus of iota 4. So this is 3 minus iota 4. This particular complex number is denoted by z bar, which is nothing but conjugate of a complex number. So where is actually this point is? So I'll be going to take minus 1, minus 2, minus 3, minus 4. So we'll be going to get one more point over here. This is 3, minus 4. So if this is representing a complex number z, then this will represent its conjugate. So join from the origin. So the diagram whatever we are getting, this is nothing but Argand plane. So conjugate means we have to change just the imaginary part, that is the sign of the imaginary part. In case we are having a complex number, say for example 3 minus 5 iota, so the conjugate will be 3 minus of minus 5, which will give you plus 5 iota. So you have to keep this thing in mind. Conjugate means change the sign of imaginary part. Now, as you have studied about the conjugate, let us take few properties of conjugate. So the first is very important property. If you take a conjugate of a complex number, you have to change the sign of imaginary part, and again take the conjugate, again that change the sign of that imaginary part will become the same one. So you have to remember this thing, conjugate of conjugate will be the same complex number. The second property that we are having, when we add two complex numbers and we take the conjugate, it is nothing but, so we can remember this one as conjugate of addition is addition of conjugates. I think we can remember this one. So that is conjugate of addition is addition of conjugates. So this can also be remembered. In the same way, we will go with the subtraction. It is subtraction of the conjugate is, the conjugate of the subtraction is subtraction of the conjugates. So in the same way, you can remember this one also. If we go with the multiplication format, it is when we take the multiplication of two complex numbers and we take its conjugate, that means bar is taken. So it will be nothing but the product of the conjugates. So we can say conjugate of the product is product of the conjugates. And similarly, if I go with the division, it is conjugate of the division is a division of the conjugates. So if you are having any problem with this one, this, for example, if you go with this one, if there is a repetition of 2 to 3 or 4 or 5, there are many complex numbers which are being multiplied. That means conjugate of the product is nothing but product of the conjugate. So this we can remember, and this can also be again manipulated, and one more result is obtained, that is if I take z to the power n, if all this z1, z2, z3 becomes z, means this becomes z into z into z into z, so this becomes z to the power n. So it is nothing but the expanded version of this particular property, that is z to the power n whole conjugate is power n of the conjugates. So this is again a property which will be used in few questions. And when we go with the division, as I've already told you, so these are few important properties of conjugates which will reduce the number of steps whenever we are solving big questions. So after this, we have, as we have studied about the Cartesian form of complex number, we have studied about the conjugate. Now let us go with one more important part of complex number, which is nothing but the modulus of a complex number. If there is a complex number given to you, z is equal to a plus iota b, the modulus, or we can say it as magnitude also, the modulus will be represented as z bar, which is nothing but square root of a square plus b square. That means we can again simplify this one as we will try to remember this one as modulus of z is square root of sum of square of the imaginary part and square of the real part. This is the real part and square of the imaginary part. So it is nothing but it is looking like as if we are calculating a hypotenuse. Again, yes. So whenever we are having a complex number, as the complex number is taken as a plus iota b, so this point is a and this point here is b, or we can remember that this portion will be b and this portion is a. So just applying the Pythagoras theorem, this OP square will be OM square plus PM square. This will give you nothing but a square and this is b square. So what is this OP? It is square root of a square plus b square. This was the derivation, but you have to remember that modulus of a complex number is square root of this one. Say for example, if z is taken as 3 plus say 4 iota. Clear? So if I want to find the magnitude, this is nothing but square root of 3 square plus 4 square, which will give you 9 plus 4 square is 16 as usual. So this is coming 25. It doesn't mean that it will always give you a perfect square. You can take it in this way also. Say for example, if a complex number is taken as 4 plus 5 iota. So how to find that magnitude? So I'll be calculating the magnitude here is square root of what it will become. It will become 4 square and 5 square, which is 16 plus 25. This is giving you 6 and 5. It is 11 and this is 41. So the result we are getting is square root of 41. So this is nothing but the magnitude. Now the doubt we should, here we are having a doubt that what is this magnitude? So magnitude is nothing but the distance of that complex number from the origin. We are calculating the length of the hypotenuse, means we are calculating the distance of the point, distance of the representation of a complex number from the origin. So it is the length, that is, we are calculating the distance of that particular complex number from the origin, which is given by the modulus. Now let us take the properties of modulus. So the property here is modulus of a complex number and modulus of its conjugate and modulus of negative of the complex number, modulus of the negative of its conjugate and modulus of z into iota, they all are equal. If you are having any doubt, let me take one complex number which is 3 plus say now 5 iota. I want to check its magnitude. This is root of 3 square plus 5 square, which is 9 plus 25. This is giving you 434, root 34. If I want to get the conjugate, it is nothing but 3 minus 5 iota. If I calculate the magnitude, again it will be giving you 34 only. That is 3 square 9 and 5 square 25, 9 and 25 is 34. And suppose if I want to find minus of z, this is nothing but minus of 3. So this is minus into 3 plus 5 iota, which is minus 3 minus 5 iota. So again if I go with the magnitude of this particular complex number, this will again give you 34. And suppose if I get its conjugate, that is minus z whole conjugate, this is nothing but again, dear student, the result here, first let me write this one as, so here till we were getting z negative, which was minus 3 minus 5 iota. If I go with minus z whole conjugate, this is minus 3 plus 5 iota. Again its conjugate, that is conjugate, that is we are taking the magnitude of that conjugate, it is nothing but square root of, again in the same way, minus 3 whole square is 9 and 5 square 25, we are getting root of 34. And in the last one, if you see z into iota, means z was this number, and if I multiply iota, this becomes iota into 3 plus 5 iota, which is iota 3 minus of 5, because iota square is minus 1. So minus 5 plus iota 3, which is again will give you the magnitude of this iota into z. If I take magnitude of this iota z like this, so we are getting 5 square 25 and this is 3 square 9, it is also root 34. So this was just a verification where we have got the confirmation that if you take the magnitude of any complex number, its conjugates, its negation, and conjugate of the negation, and multiplying the complex number with iota, the conjugates are here same. Now, so magnitudes are same. Now, if I go with the second property, that is product of a complex number with its conjugate. That means, as we have taken, I am taking the same example, 3 plus 5 iota, yeah, iota 5, or we will be taking the conjugate. Here the conjugate will be 3 minus iota 5. When I take the product of a complex number with its conjugate, which is 3 plus iota 5 and 3 minus iota 5, this will give you 3 square plus, why this plus is coming? Because iota square is minus 1. So, this was 5 only, this is iota 5, and here this becomes 5 square, which is coming 9 plus 25, which is 34. 34 is nothing but square of its magnitude. So, very important property whenever we are having any question dealing with the modulus of a complex number, we will be going to take this property. And when we go with the third one is product. So, we can remember this one as modulus of product is product of the modulus. So, this property can be remembered very easily, and if we are having product of n number of complex numbers, say z1, z2, z3 and so on up to zn, it will be product of the magnitudes or the modulus of all those complex numbers. In the same way we are having for division. For division also the same concept is there. Modulus of the division is division of the modulus, and this was been obtained as it is the derived part of this property only. If all the complex numbers are all z, this becomes z to the power n. So, we can say modulus of z to the power n is power n of the modulus of z. So, this you have to remember. Now, when we come to these two properties, where this one is very important, this is known as triangles inequality. Why we are saying triangles inequality? Sum of the two complex numbers, and when we take the magnitude, let me tell you that Argand plane, as we are having, say for example, if there is a point given to you, I am joining this one, this is nothing but magnitude of z1. And let me take one more complex number here, q, which is nothing but magnitude of z2. Clear? Now, when you add the two complex numbers, so here let me take that this point is this point is 1, 2, 3, 4, 4. So, if I am representing this one as 1 plus 4 iota and this point as 1, 2, 3, 4, 5. Let me take this one as 5. So, this point is coming 5, 2. So, this second point, the first point, that is 5 plus 2 iota. If these two are two complex numbers, when you add them, so when we are going to add them, this is 1 plus 5, 6, 4 plus 2 is again coming 6 iota. So, the addition will come where somewhere here. This is 4, 5 and 6. So, you can see that the point will be going to come somewhere here. Now, I am drawing this one with some other different color. Let us take that this point is there. Now, complete this one. So, we will be going to get a parallelogram. That means, if I join this particular part, this is nothing but z1 plus z2. So, magnitude of this z1 plus z2, now this is representing a triangle. And as we know in triangle, this is magnitude of first complex number, this is same, this is magnitude of the second complex number. So, triangles inequality means sum of the two sides will always be greater than the third side. The third side is actually addition of the, it is magnitude of the addition of the two complex number. So, magnitude of the addition will always be less than or equal to sum of their individual magnitudes. And this one is again an intermediate part. When we go for squaring of any complex number, we have to take the help of this particular property. This can also be derived very easily. So, these are few important properties of magnitude. This will again help you in simplifying the terms much more easily, that is less number of steps will be there if you use these properties. Now, apart from the properties of conjugate and modulus separately, we are having three more important properties of the complex numbers. So, which will be going to come in any of the question, where we can remember that the sum of the complex number with its conjugate will be always equal to twice the real part of the complex number, which is nothing but again purely real. So, this property can be remembered. The other one is when I take the subtraction. Subtraction means from the complex number, take away the conjugate of the complex number, we are going to get imaginary part. Along with that, since iota is there, we say it as purely imaginary. So these are two important properties which we'll be going to use. We may get few questions in this property when we apply, and this we have already studied, that is product of a complex number with its conjugate. So these are three important properties which you have to remember for solving the questions. Now, one last part that with which we can solve the questions later on, that is nothing but the reciprocal of a complex number. So dear students, as we have studied about multiplication, the division is already been taken. Division is a multiplication of a complex number with its what you can say reciprocal. This reciprocal is nothing but it is the multiplicative inverse, because when I say that Z1 is divided by Z2, this is nothing but Z1 is multiplied by 1 upon Z2. This is known as reciprocal, or we say it as multiplicative inverse of complex number Z2. So we should know the technique of finding the reciprocal. Already we have studied that we have to multiply, we have to rationalize the denominator. This we can remember as, when we say that reciprocal of a complex number, this is 1 upon Z. It is also written as Z to the power minus 1. Let me write this one as Z. And the property that we have studied, if any complex number is multiplied by its conjugate, that means I am going to multiply this term by the conjugate, that means Z bar and Z bar. So we are multiplying by Z bar and Z bar in the numerator and denominator. What we are getting? We will be going to get Z bar, that is the conjugate of a complex number. In the denominator, we have studied the property. What was that property? That property was Z into Z bar is magnitude of Z square. So this property we can apply here. This we can remember this one as, this is magnitude of Z whole square. So do remember this property, because for few small questions, suppose if I ask you, that is if there is a complex number given to you 5 plus 12 iota, if there is a complex number 5 plus 12 iota, write its reciprocal. So the reciprocal can be written very easily. That means I want to find Z to the power minus 1, we will be writing 5 minus 12 iota whole divided by square of the magnitude, which is 25 plus 144. It's a Pythagorean triplet, so we are getting 169 in the denominator and 5 plus 12 iota. So we can write this one as 5 upon 169 minus 12 upon 169 iota. So this one is the real part and this is the imaginary part with that minus sign. This is how we can do the reciprocal of a complex number.